Pilothouse panel. This big gray thing is the PLC. It's the main PLC. As you can see, the green color, the cable coming into the PLC, going over to this guy, which has a box, and this is the main Ethernet switch. So you see green color come from the PLC, go to the switch, then leave the switch, and goes out to one of the lays, another lay, another lay, another lay. Then come back here, back into the PLC, makes the ring. This guy and the PLC work together to manage that ring. When we're going to come down here, first while we're on it, this box here, big 6 and big 7. This ties into the ground fault discussion we're having. At our houses, they drive big copper stick into the ground, and then we reference the neutral or the power to that ground, and we have ground fault interrupters, things like that. On a boat, we don't have that. The whole boat becomes a giant, big old capacitor. It takes years to fill it up. But in the meantime, this voltage runs all over the place. So if you took your meter and you go from big 7, which is a negative, it should be nothing. Maybe 100 millivolts, because there's always some bullshit floating around on the boat. When you go from big 6 to the hull, it's going to be 24. Okay, because it's not entirely isolated completely. So if say, let's say torque transducer on the leg, for example. Something happens inside the low circuitry, and it shorts itself to the hull, that close to the to the HPU panel, to the LP, the XLP. And you go from big 7 to the hull, and you have like 2 volts. Time to find it. Sometimes you can find it in 5 minutes, sometimes it takes 5 days. Ground faults are a bitch. But these ground faults can also affect, like Mel said, CANbus communication. Typically does not affect the profile net. Okay, so we have big 6, big 7. Since we're in this neighborhood, let's talk about this. This guy here, that's the circuit breakers for the AC power coming in. So that's the 2 circuit breakers, one for AC coming in and one for the receptacle. Okay? So AC power is in this box. In this box is DC power supply. These guys are monitored by the control system. There's 2 in every panel. So if one fails, you get an alarm on the screen that says, hey, DC power supply number 1 not working, but DC 2 still going. In fact, this is the circuit breaker out of this one. This is the circuit breaker out of this one, and they go into this guy, and you can put in this box diode. This allows me to take the 2 power supplies and send them out of a single supply without this disparity of power. Comes into the AC. Your AC comes from the transfer panel. That AC feeds both power supply. Both power supplies go through these 2 breakers into the diode. So it's plus in, 1 plus out to big 4. And the negative that comes here goes directly to big 5. And we stop. And then the switch upstairs makes 6 and 7 go hot by another relay we call the trigger relay. So the switch doesn't do anything except a relay. Okay? So this is all of the power here. And these wires are the alarm contacts that tell the PLC to tell the screen, hey, DC power supply bad. So when one's dead, you have time to get a new one before the whole thing goes to shit. So that's the power section. So this here is the power section, and that's that. Huh? Okay. This box, Gateway. If you remember, we talked about the J1939 being CANbus and the PLC and the big granddaddy being green color Profinet. This guy, he talks CANbus to Profibus. And you can barely see it, okay, but you see this little gray box here. Oh shit, guess what, fellas? This is supposed to be purple color. Evidently Vietnam did not have purple color. This is the Profibus line. It comes out of here, goes up and plugs in right here in the PLC. So in the PP, you better make a note, Profibus is black color. So this is the we call it the J1939 gateway. And if you look real close, you see 3 green color LED. It should always be green. If one is red, it means there's been an upset in the CAN bus. If you cycle power and come back and they come out green, it then reset itself. A lot of the stuff on the system, if it don't compute, reboot. Okay, what's this pointing to?
Black box.
Black box. Even though it's blue color, it's black box. This little red Ethernet here plugs into the PAX Diamond internet right underneath the panel on the wall. Okay. This is one of these. This is regular Ethernet. This has nothing to do with the BJ color.
Yeah.
Right? This red color is CANbus. This black color is Profibus. This green color is Profinet. This here is bullshit, whatever. It could be blue color, it could be clear color, it could be anything.
I got it.
Okay, this here empty?
Yeah.
Yep.
Okay, this points to 3 relays. 3 in PP.
3 relays.
Yeah, 1, 2, 3. If you look real close, one says JST. That stands for Jacking System Trouble. The other one says 150 and 250. That stands for 1.5 degrees and 2.5 degrees. When the inclinometer reaches these levels, we actually close these contacts on top of sending the alarm to the screen so that this information can be sent to your AMS. Your AMS, the ship's alarm management system. Now, my personal view, 1.5 and 2.5 for a four-legged boat is way too much. Way too much. I'm not gonna allow the vessel to jack anymore without aggravating the hell out of you more than 0.5. Now, when you liberate, okay, and if you're sleeping and it does go in a can hole, we want it to go off. That's why you never disconnect the horn, because that is the secondary inclinometer for the vessel. Okay? So that's what this is. These 3 relays talk to the alarm management system for the vessel. This is an interface, very important. Now, the JST is one of my favorites. I know there were some questions in Mel's training about the alarms and how they work. So we have important, kind of important, pretty important, and we want you to know. And we treat those differently. So on the screen, if it's really important or kind of important, the horn goes off. Okay? And you have 30 seconds to acknowledge the horn, with the idea that if you're there on the sticks and you have a really important, you're going to do something. If you're not there, let's say you're preloading and you're waiting or something, and there's a massive leak somewhere and you drain the oil and it goes off. If the horn blows for 30 seconds, JST coming, AMS gets the record, then everybody knows, whoa, something wrong with the jacking system. Very important. Some of the other ones, for example, yeah, like DC power supply, that's a good one. If you lose one, I'm not gonna stop you. As a matter of fact, while I'm thinking about this, our control system never stops you. If you're in trouble, you need to jack this boat. Even if you're gonna ruin stuff, you save the boat. You don't, some people shut stuff down, like, for whatever reason. We do not shut you down. We just tell you, you better fix this or you're gonna break something, but you can still jack. Because sometimes you gotta jack in a hurry. It's not too common in the Persian Gulf, but in the Gulf of Mexico, there's places where these heavy boats would just push down 5-6 meters without warning. After you preload even. It's called punch through. Scare the hell out of you. You need to get that shit fixed quick or you're gonna go over. So when you see an alarm coming, especially if you hear the horn blowing, you need to do something immediately. So, this is an important box. This white, yellow, and blue wire on these terminals is the CANbus connection. See, green color have these fancy metal connectors for the Profinet. They plug in, it's all fancy. The Profibus has this even more fancy connector, but the CANbus works with wire.
Wire.
And you got to put a resistor on the end on purpose. A real resistor with the lines on it. It's none of this fancy shit. CANbus is for men. But this is where it's at. And if there's trouble with CANbus, while I'm thinking about it, you turn off power and you measure the CANbus network line. You should see 60. If you see 30, something's wrong. Because the CANbus network, peak, it goes from the leg to the leg to the PP to the gateway to the joysticks, then back out to the leg, all one run. It's usually pretty good. Why? Because it's wire. If you want to kill the computers upstairs on the wheelhouse on the bridge, that's it. One for each one. So this is HMI DC supply. How's that? Why do they got to be AC because we got UPS. So it's AC. Sorry. Whoop.
AC.
This is let's call it dimmer controller, and I'm gonna explain why. This dimmer.
Dimmer control.
It's the most expensive dimmer in history. This is actually same as the pump controller in the leg panel. The original idea was to use this fella as a grandfather for the pump controllers around the boats. It wasn't fast enough for me. So we took it out, but it was already in use for the dimmer and for some other permissive stuff, so we left it. Right now, its really only job left is to manage system ready to the pump controllers, and it handles the dimming. This one is important. Any idea what that is?
Inclinometer.
That's the inclinometer. As you can see, one manages the roll and one manages the pitch. And they should never have to be messed with. So this is the PP. Anything you ever wanted to know about the PP, I will show you the drawing so you can see how all this stuff talks to one another.
Yeah, now I understand everything.
Okay, see, remember we talked about the AC coming from the transfer panel? Comes into the circuit breaker right here. Remember the circuit breaker on the left? If you look at your picture?
Yeah.
Okay, and it comes through here and it goes to the two power supplies.
These two.
Then it comes out the power supply, goes to the diode. Big 4, big 5, big 6, big 7. Voila. This is the Ethernet switch that's on your picture. Okay. This is the JST and the 150 and the 250 relays for the AMS. Remember? Inclinometer. Now this is the whole PLC. That big gray thing on the top is the very first box we filled in. And what happens is the PLC brain manages through all of the programming, inputs coming in and outputs going out, and when this happens, that happens. When that happens, this happens, and different things, and then we all put it together and then program it some more and send it to the screen so you can use it, see it, and operate from it. This is the gateway. And this here is all the connectivity to the very expensive dimmer. Okay? Everything else in here is very simple. And then remember PCA and PCB? Okay, this is PCA. See the joysticks? See, this is all CANbus. So it comes in, goes back out. And then this is PCB, which runs the motor start buttons. And these four things are my favorite. Those are the triggers. So when we turn on the key and all this stuff happens and everybody's happy, these relays fire and we send voltage to another relay at each leg panel, wakes them up. So they can use their own power. We just have a little bitty baby signal of no required strength, and then that big trigger relay downstairs wakes up and the panel wakes up. So this is page 1 of 46 pages.
Wow.
Fuck me. This training and other videos on this channel are produced to educate the crew and all involved personnel. Feel free to use them in your training sessions.